I don't know about you, but I'm getting a little antsy to start making some chips. We've covered a lot of the basics, different machine operations, the types of materials used. Now, let's show you the proper way to prepare that piece of stock for a project. We've got a piece of tooling plate that we cut, 1¼ inch thick by 2 3/4 by a little over 4 inches. You can see when we cut it off in the saw, we've got a rather large burr here. And this is part of the stock prepping procedure. We simply wouldn't cut it off, set this material in the vise, and go to work on it. We're going to take a file, 6/8 inch single cut file, works really well, and we'll go around all of the edges of that material. Remember to push the file at approximately 45 degrees to the part. The file cuts on the forward stroke. We're going to go through and basically burr this entire block, so when we set it in the mill vise, we don't have any burrs, nicks, or dinks affecting the parallelism of the part. You can see we've got a big dink here, so we're going to use that as our first cut to machine that away on the top. Take your time during the stock prep. It's very important when we get ready to square and true up the block that we've done this. Each time that we make a cut on the part, we want to check it for a burr. We don't want to be switching back and forth and forget that we've got a big burr on one side that will later affect the accuracy or trueness of the part that we have. Take your little paper towel, wipe the filings off of the block, and then I get in the habit of just running my hand over the block from time to time, making sure that I haven't missed anything, okay? We can take our file and run it over that surface, make sure it's flat. Usually the milled slabs that you see from the manufacturer are going to be pretty true, so we can use those as a baseline. Run our file over them, nice and smooth, remove any filings that we have left on the part. All right, so we've prepped this piece of stock. We're now ready to set it in the mill vise and make our first cuts in order to get it truly square and parallel. We want to wipe our vise jaw nice and clean. Again, we don't want to be setting it on any parts or chips that will cause it to not work off of the vise jaw. The rear jaw I like to refer to as the master jaw. We've dial indicated in, if you remember earlier when we mounted the vise, these particular vices are ground true and parallel within a couple of tenths of an inch. So they're very, very precise. We're going to set this block against the face of our vise. Now, if the block is not parallel or tapered, when we clamp it, it can be shifting in the vise one way or another, and you go, wow, that's a real problem. How do we overcome that? A neat little trick that's often overlooked by many folks these days is simply take a piece of round stock, put it in behind our block where we're just pushing on the center of the vise jaw and tighten it down, okay? We've ensured that this face is clamped securely against the face of the vise, and now we're going to go ahead and take a pass across the top of the block. We can do that with an end mill. We can do it with a fly cutter. Let's start with an end mill, and I'll show you a little trick to significantly reduce the amount of burr that we get on the part by cutting this in a climb cutting method across the top. You've watched a couple of times. We'll go over the final details of securing the collet in the chuck. You're going to have a little nubbin in the chuck that tracks off of the R8 collet. It's a little guide that's in the spindle that matches this slot to keep our R8 collet from spinning in the spindle as we tighten it up. So we'll simply insert it, rotate it around until it lines up, push it in place. We're going to reach to the top of the mill head, and we're going to finger tighten the drawbar to suck the collet into place. Once we feel the draw nut come up tight, we're going to insert our end mill, choke it up nice and tight, reach up with our wrench, and we've noticed the brake on the top of the mill. Okay, we're going to put the brake on as we tighten the drawbar. Get it pretty snug. We don't want to twist it off. We don't want to damage the collet. We're going to bring our cutter down in contact with the work. Okay, remember to keep the quill handle in the proper relationship. We don't want to be pushing forward with the quill handle. All right, and I like to start on one end of the part, so we're going to move the table in what axis? All right, the x-axis. we'll center up our cutter, bring it down until we just come in contact with it. We're going to unlock our quill. We can go ahead and set our stop. Quill stop, run it up. You can see how I'm using my thumb. I've got about 1/4 of an inch spacing between the stop dial and the actual lock nut. And as I run my thumb across them, we're turning them up at both about the same level. So we're not playing chase. One locks into the other. Okay, we're ready to go. On this particular cutter, we're going to turn it at 1115 RPM. We'll advance it and just scuff the top of the workpiece. We know we're in contact with that. We're going to raise the bed of the mill 20 thousandths. We're going to take a 20 thousandths cut the first time. Rather than go down the center of the part, we're going to index over to the left, and we're going to cut around the periphery of the part, removing the burr from the outside edge. So we'll index our cutter over, give ourselves a shot of WD-40 across the top, and advance the cutter where we're just cleaning up the top edge, cutting into the top of the part, forcing the burr off of the part. In a production process, if we're doing a lot of these blocks, this will save us a tremendous amount of time in cleanup and burring. Okay, you can see that our block was out of parallel a little bit. We didn't clean up on that side. So let's go around to the other end. Okay. You're getting a little bit of an optical illusion with the cutter on camera. Don't worry about it. Just watch the direction of travel of the cutter. We'll go back and let's take another 20 thousandths off. Okay, in this fashion, the cutter is rotating clockwise. This would be a climb cut in a facing operation, okay? We're simply facing the top of the block off in a climb cutting motion, taking the burr from the outside edge, forcing it to the inside edge of our block. Run your cutter all the way to the end of the block rather than stop. Now index it over. We'll run back the other direction, and we're going to see a little center stripe start to appear in the top of the block where the two passes of the cutters intersected. Again, we're going in a climbing motion as we're moving the bed from left to right. Remember, we want to have a nice, slow, deliberate feed rate. As we become more advanced, we can go ahead and put the power feed on. But I want to get your basic mill handling techniques down. All right, now you can see we've got a nice smooth surface on the top of our block where we've indexed our cutter over, and by climb cutting, if we're to run our fingers along these sharp edges on the sides, we don't feel a burr. If we were to cut in a conventional method, forcing the material off in this fashion, it would raise a burr on the outside edge. So with this part surfaced on this side, simply remove our bar, take our vise out, or take the part out of our vise, and as a matter of habit, we're going to go ahead and take our file and just for practice, put a little chamfer on that outside sharp edge. Okay, usually 3 or 4 passes of the file. We'll try and give you a close-up view of that so you can see the width. You can see we're just breaking that razor sharp edge with the file. Make sure and wipe the part off again because we've got little chips and stuff from our milling operation. Be sure and clean the vise out. If you don't have stock in a paper towel company, I strongly suggest you do it, that or the rag company, because you're going to be using a lot of rags, keeping the vise clean, keeping all of the chips out. Once I've done that, I like to take my thumb and just run it across the vise jaws, making sure that there's no residual chips left. All right, we're going to take our machined surface that we just machined. That's going to go into the bottom of the vise. This was the face or surface that we had against our master jaw. So we're going to want to repeat that as we insert our part back into the vise. Push it up against the master jaw. Grab our piece of round stock. hold it down, okay, and tighten our vise up. We don't want to scrounge down on the vise. The vise exerts tremendous holding force. Simply snug it up pretty good. And we're going to go ahead and resurface this top edge. What is that going to do for us? You guessed it. It's going to make those two surfaces parallel and two dimension. So we'll go ahead and take another pass across that. Then we're ready to square the ends of the block. Remember now, we've made our adjustment on our quill. If we're to run our cutter across the top, it's just going to barely skim the top of our part now. So we're going to raise the bed in the Z-axis another 20 thousandths of an inch. Give our cutter a little shot of WD-40 across the top of our part. With a nice smooth feed rate, advance the cutter across the top of our block, cutting to a specific height. Remember, on the knee, our dial is in 100 thousandths per revolution. On the cross feed, on the X and Y axes, our dials are in 200 thousandths per revolution. Index our cutter over, down the top of the part. It's a very light machining operation. Again, we're taking only 20 thousandths off and surfacing the block and bringing it into a desired dimension. Take our towel and again wipe our part off, getting a lot of the chips and stuff out of the way. Okay, we have our back reference pushed against our master block. We've created this surface and the bottom surface parallel and to dimension. Now we're ready to square the ends of the block. If we're to run our dial calipers, check that into the block. We've got 2 inches, 620 thousandths on this side. 2 inches, 620 thousandths on the other side, okay? Always get in the habit, again, of checking our part. If we were to get a chip inadvertently in the vise underneath the part, it would cock it, and those two ends would not be parallel. Okay, with our vise jaw clean, it's now time to insert a couple of precision ground parallels, and I'm going to show you another trick that I've learned over the years, and that is to keep the parallels in place. Simply give your vise a little shot of WD-40 or any other type of spray oil, and this allows the parallels to, in essence, stick to the jaw at that point, okay? They kind of bond themselves there with that oil. We can tug on them a little bit, and we can't break that bond. Make sure that your parallels are nice and clean and they're free from any nicks or dinks in them that may affect the accuracy or parallelism of the part that we are setting on top of them. I like running them back and forth once I mount them, and this allows you to feel any clinkers that may be underneath the parallel, okay? So just get into that habit again. It's stuck to the vise jaw with the WD-40. Go ahead and open our jaws a little bit. You can see now that we have a depth of approximately a ½ inch here. The depths of these jaws are 1.5 inches. So we've got a ½ inch of our master jaw to set it against. We're going to go ahead and set our block in. In this fashion, we can retract our parallels a little bit because we're going to go ahead and square this surface now. We dialed in the back surface of our master jaw, so when we work off of the y-axis, what is going to occur? This surface and this surface are going to be exactly 90 degrees or perpendicular to one another. This is how a mill works. A mill makes things square and perpendicular to one another. Just like the lathe turns things in a round, cylindrical fashion, faces them off square, etc. Okay, so we're going to protrude about a ½ inch outside of the vise jaws. We want to take and push our part down on top of the parallels and slowly tighten the jaws. And you'll see that we tightened it and we loosened it a little bit. This allows us to feel what the part is doing when it comes under clamping pressure. If we start to clamp the vise up, and with our fingers on the top, if we feel the part start to drift or tilt, we know that something's wrong. At that point, stop, check everything, make sure that we haven't found a chip that's worked its way underneath the part, affecting the accuracy and layout of the block as we put it in the vise. Everything feels really good, and this is about the minimum that we would want protruding above the vise jaws on a part this thick. Okay, we wouldn't want to mount it in the vise where we just had, let's say, a 1/16 of an inch of grip on the parts. Okay, that's not a good idea. Try and get as much surface contact on the vise and on the part that we're dealing with, so we've got a good, what? You guessed it, a good secure hold on the part. Okay, we'll take our cutter. We're going to raise the bed up a little bit so we don't have to extend the quill down nearly as far. Move the table in the x-axis to get the cutter over on the side. Okay, we can go ahead and lower the quill at this point. Run the cutter up on the side. Make sure that the cutter protrudes below the thickness of the part. We've got a little bit of a radius ground on the edge of the cutter, so again, you want to make sure that that radius extends below the part so we get a real nice flat surface. We don't want a little bit of a radius being machined on the bottom of our part, which will overall affect the squareness of things. Once this is in position, go ahead and lock down the quill, and we'll turn the cutter by hand now. If we're cutting, you can see the cutter rotating this way. If we're to move the cutter this direction, that is in a climb cutting mode. And anytime we take climb cuts, we want to have a very small amount of chip load in the cutter at that time, because what's happening is we advance the workpiece into the cutter. It's trying to walk its way along or climb its way along the top of the part that we're machining, and this can be rough on the machine. If we're to take a real heavy cut and we try climb cutting across that and have a real fast feed, we can literally shear off or break that cutter as it becomes really aggressive trying to grab more material. If we were to turn this direction and pull the cutter this way, this is called conventional milling. Okay, we're scooping the work out. The work is resisting the thrust of the cutter as it's being fed manually by the table across the part. We can go both directions to remove a maximum amount of stock, but the heaviest amount of removable occurs when we are in the conventional cutting mode. Okay, watch, we'll show you both methods. Bring our cutter over to the end, come in contact with our part, index over, desired amount of material that we want to face off, and look at those long chips just peeling off of the part, okay? This is conventional milling now. We're forcing the cutter into the workpiece. We'll change directions now and take a climb cut. We'll take maybe 5/10 thousandths at that pass. Again, the cutter is climbing its way across the part. It's going to give us a little superior finish along this line, so when we make our final dimensioning, we can take the last 5 or 10 thousandths off in a climb cutting mode. Notice the chips coming off are a lot finer than they were when we went into the conventional mill. We were removing a lot more material. Okay, we've got a beautifully machined, slick, polished finish. It almost looks like we ground it. We've got a good sharp cutter. We used a real good lubricant. Even though it's cheap, WD-40 works really well. And now, if we're to check the back surface with the surface we just machined, those two would be perpendicular to one another, exactly 90 degrees, because we moved them on the XY axis. Okay, so now we can turn our part around, machine the other side. Be sure that we clean all of the chips off of it. We don't want this to affect the accuracy of our block. We're well on our way now to getting a part ready for the final machining process. Take your paper towel, wipe those parallels off. Another advantage to putting the WD-40 on the parallels is that it seals them up against the vise jaw, and we do not get a chip in on the back side of them. Make sure that we wipe our hand across the part, checking for any chips or debris that may be there. Check both sides that are we going to be clamping in the vice jaws and very carefully set our part down. Put our fingers in the top, pushing it down, and tighten our vise, loosen our vise, and see if we can feel any shifting in the part. This is very, very important. Okay, hit it with the heel of our hand, lock it up, advance our cutter down, and we're ready to take another conventional mill cut in the roughing removal of our stock. Come in contact with the work, index over, take another 20, 30 thousandths. We're going to conventional climb, removing the bulk of our material. Now we're going to come back with a climb cut, 5 to 10 thousandths for our finished pass. Listen to the machine. We've got a very uniform throbbing of the cutter as it's removing material from our aluminum block. If you hear any abnormal noises or it sounds like it's crushing rocks, stop and see what you're doing wrong. Either we're taking too much material in the cut, we've got insufficient RPM in the cutter relative to our feed rate. There's a balance that we achieve here. We're going to show you a formula a little bit later on that tells you specific feeds, RPMs, feed rates, etc. But again, as we mentioned earlier, when we're dealing with a step-pulleyed Bridgeport mill, we're dealing with specifically 8 speeds, 4 in back gear, 4 in direct drive. So those speeds have been chosen by the manufacturer to be the most versatile for the different diameter cutters that we are using. You're going to find that for most of the cutters that you're dealing with in general machining operations in direct drive, 660 to 1115 RPM are about optimum for cutters up to 3/4 of an inch, again depending upon the type of material and the hardness of the material that we are machining. All right, let's wipe our aluminum block off and take another look. All right, we've got another beautiful machine finish at that point. All right, now it's time to surface the top of our block that we have setting in the vise. But first, we're going to need to remove our cutter and replace it with a fly cutter. Remember, we used the fly cutter earlier on. It's a larger diameter cutter where we can surface the top of this part in one pass. We don't have to take the end mill and run it back and forth across the top. We'll get a much more uniform and consistent surface finish as well. We've showed you how to install the cutter. Now, here's a couple of tips and tricks on how to remove the cutter and replace it with a fly cutter. We're going to reach to the top of the mill and apply the foot or hand brake. Put our wrench on top of the drawbar. With the brake on, we're going to go ahead and break the cutter loose. Once we see the wrench is starting to turn freely, we can loosen our grip on the hand brake. We're going to reach down and with our index finger and thumb, grab the cutter as we continue to loosen the drawbar. Once the drawbar is loose, I like to take the wrench, or you can take a plastic hammer and simply tap the top of the drawbar, and that breaks loose the collet from the cutter, separating the two for removal. Take your right hand, take your middle finger, put it on the collet with the left hand at the top, and we're simply going to spin the drawbar off, releasing the collet from the spindle. Okay, very important. Don't drop the collets, don't drop the cutters on the workpiece. If you're dealing with a carbide cutter and you drop it out of the collet on the workpiece, there went a $40, $50, $60 cutter because it's going to chip and break. Make sure that we've removed all chips from the R8 collet when we get ready to install the other one. Insert it, rotate it until we find the guide, reach up, engage the collet with the drawbar by turning in a clockwise fashion, and we're now ready to install our fly cutter. Choke the fly cutter up nice and tight. We want to have good rigidity in any cutting operation that we engage in. You can see we've got about 3.5 inches of depth between the fly cutter and our surface part. We can go ahead and raise the knee, again keeping a very rigid setup while we're machining this. You can also bring the quill down if you want. I like maybe bringing the quill down an inch, inch and a half. We're going to bring the cutter down towards our workpiece with the quill and watch until the cutter just comes in contact with the top of the workpiece, okay? At that point, we're going to reach over and lock the quill down. We're going to go back to the knee and our Z-axis And in a counterclockwise motion, we are going to lower the table 5 thousandths. So now if we advance the cutter is not scuffing on the top of our part. Okay, we'll do this once the cutter is running and we're ready to advance it into the workpiece. Remember, when we're using a fly cutter is not for rapid removal of a lot of material. It's simply to surface the material. A heavy cut with a fly cutter is usually 50, 60, 80 thousandths, not much more than that, depending upon the type of material that we're doing. Very fine amounts of material can be removed in order to surface the top of the block. So we're going to go ahead and back the cutter away from our block. Okay, we've got clearance now, so when we turn it on, we're not ready to cut. We're going to go ahead and advance the cutter over the top and very gradually raise the table the 5 thousandths that we did when we lowered it. Okay, so now we're in contact with the block. We've started cutting. We're going to take about 3 thousandths off the top, shoot our block with a little WD-40 and on the cutter, and with a very smooth uniform motion advance the cutter across the top of the workpiece, creating a mirrored polished surface. Okay, remember we want nice smooth uniform advancement of the table and the fly cutter across the part. We're rolling the dial in the palm of our hand just like it was on a power feed. All right, with that complete, we'll turn off the mill, wipe our part down, again clean the vise jaws, and we're ready to flip the part over and surface the other side. Okay, before we do that, for those of you that have your thinking cap on, what is our next procedure? You guessed it. We're going to run a file across these edges, making sure that we don't have any burrs on that part. So very gently push the file across at approximately 45 degrees and just break that razor sharp edge that we've created. Want to have a nice, smooth, uniform facet on all of the sharp edges on the block. We don't want to have it real thick on one end and trail off to nothing on the other side. Okay, once we've done that, take our paper towel or rag, wipe our block off, getting rid of any chips or debris. Take the palm of our hand. It's amazing what you can feel with the palm of your hand. Don't always take for granted that just because we've wiped it off with the rag that it's absolutely spotlessly clean, because it will not be in many cases. Set our block down and go over and make sure that our vise jaws are clean. Also, once your rag or shop towel becomes saturated with chips, it's a good idea to trade it in on a new one, okay? Every now and then the gremlins will start playing with your head, and as you wipe the towel across it, it just deposits little chips behind you. Okay, so we're going to push down with our left hand, tightening the vise with our right, break it free, and see if we can feel any disturbance or shifting of the part. And this feels really solid. Go ahead and tighten down our vise. Turn the machine on. We're going to come back in the other direction with a 10 thousandths cut. Lock our knee down. This is our final pass. Give our part a shot of WD-40 and very slowly advance the cutter. I always like watching the stream of chips coming off the cutter. Reminds me of a machine gun in action, just kicking those empty cases out, maybe on the charge of San Juan Hill. This is a good indicator as to whether your head is trammed in as well. When we bring that cutter across, we want to have a nice uniform trail picking up our cutter as we go across, creating a nice uniform finish. All right, there we go. We've now created a block that is gauged to size. All surfaces are parallel and square to one another. This block is now ready to machine a part from. It's very important that we start off with a good reference material. If we were going to machine 100 of these parts for second and third operations, and we were to set up a work stop in the mill, they have to be the same size. If they're varying 5, 10, 15 thousandths, because of sloppy machine tendencies or workmanship on our part, the result's going to be scrap as we start to put them into a master or run them up against a work stop thinking that they're all the same size. Take your time, make sure that all of our setups are spotlessly clean, we don't have any chips or debris that may affect the placement of our block. Make sure that we take our file, we go over all of the sharp edges that we've created in the squaring and truing of our block. Okay, that pretty well covers the squaring and truing operations. Let's move forward.